Hey everybody, this is Larry. This is day 22nd of the Leetcode Day Challenge. And there's a weekly challenge. Okay. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Oh, it's an easy one, so we're glad that we can have a weekly tougher one. Well, maybe anyway, I don't know. 392 is subsequence. Given two strings S and T, return S, or return true. Wow, return S. Wow, I really can't read, huh? Return true if S is a subsequence of T or false otherwise. Subsequence of a string is a new string that is formed from the original string by deleting some, can be none, of the characters without disturbing. Okay, I mean, yeah, this is a pretty standard thing. I guess it's not technically needle in a haystack because it's a subsequence. But basically, the idea behind this one is just greedy. I think most people probably, it isn't easy, so I think most people shouldn't really struggle with this one. Should do it as fast as you can. I think you might not necessarily think about all the proofs and stuff like this, which I don't know. I don't know if I'll be able to do a good job, but I'll make an attempt. But the idea behind this one is going to be greedy. And the reason why I want to go over it slightly, I'm not going to spend too much, I'm not going to dwell on this, but it's just that this kind of concept comes up in other problems, right? And I think I think one thing that I talk a lot about, but maybe not on a easy video, but on harder videos, or more difficult problems, where I go, oh yeah, the reason why I know X, Y, and Z is true is because I did X sometime in the past. And this is kind of one of an example of one of those like smaller digestible parts, right? Where you kind of know the reason, not just know why, or not just knowing the solution, but knowing why to the solution and how to the solution, then you can kind of extend it when you get to harder problems, right? And it's sometimes it's easy when, especially, I think that's one thing that one thing that's a little bit tricky with studying on your own is that you're given a progression, right? And in a sort of a progressive kind of way, it's very easy to kind of go like, today I'm just using a dumbbell analogy. Today I do the bicep curls for 3 pounds. Next week, 4 pounds, 5 pounds, right? It's very, every movement builds off the previous week, and so you're kind of knowing what to expect, right? You in the beginning you're just learning how to move the weight around, let alone gaining strength or gaining muscle, rather, maybe depending on what you're aiming for, and you're getting strength not from gaining muscle, but you're getting strength because you're just learning how to use the weight and everything in the beginning, right? And it's the same kind of idea with these kind of thing, is that you have to kind of play around these things anyway. And in particular for this one, the idea is greedy, right? And the greedy proof, and maybe it's not like a 100% tight mathematical proof, but the proof of this is kind of and is something that comes up in both obviously subsequence cases, but also other cases. And this is the greedy part, where basically the idea is that in theory, right, in another idea, there are many choices for each character, right? Meaning, if a character has like 6 A's, then maybe you have to choose one of them, and you don't know which one to choose yet, right? And the idea is going to be greedy. Why, right? Well, greedy here makes sense because, and what I mean by greedy, and what I mean by greedy is just taking the first character that you see that matches, a lot of times greedy kind of makes sense in the sense that you're like, oh yeah, obviously it's intuitive, duh, right? But then that's how you also get in trouble, because there are a lot of problems that even if the answer is greedy, it might not be greedy in the way that you think it is. And also, yeah, of course the answer is easier with greedy because there is a very quote unquote obvious optimal subproblem. No, that's dynamic programming. More like optimal choice or decision at every step, and you're like, well, yeah, obviously, but it's not actually always that obvious, and that kind of like mindset gets you in trouble a lot, especially when it comes to at least for me anyway. So maybe you have a different kind of nemesis, but for me, like when it comes to sorting by certain things, sometimes it's not always clear to me which way to be greedy, right? Like if it's multi-dimensional, for example. So anyway, and it's worth kind of thinking about, well, why does greedy work? Why do you want the first string to be true? And the answer is actually pretty, not that bad, not that long, even though I spent a long time getting into it. It's because, in a way, if you're greedy by choosing the first scene character, you're basically leaving you more choices, right? And it's the idea of this, like, leaving you with the most future possible decision as you want. So that's kind of one way to look at it. That's all I really have. I mean, this is should be an okay problem if I didn't misread it or miscode it, which I have been known to be doing the last couple of weeks. But yeah, so I mean, it should be okay, right? So so maybe we'll do like some T index is equal to 0, and then for C and S, right? While T index is less than let's say Tn is equal to length of T, maybe NT, I don't know, right? While T of T index is not equal to C and this, then we increment by 1. Otherwise, if T index is equal to Tn, we return false. Otherwise, this matches, so we still have to do a T index plus 1, and then that's it, I think. Right? Maybe. Easy to mess up. T in the 0. So, it has to. I think this is right. It's just that I kind of put in the wrong order because I don't know. Apparently, I can't even get a while loop statement, right? Sometimes you're just having that kind of things, right? Am I good? I'm probably good. Let's look at that later. Okay. Oh, yay. Okay. Just want to make sure I get it right first. I mean, you can't really do much faster, so I'm not really worried about this. I mean, I think there is some, optimization. Python is a very weird language for Leetcode with respect to runtime, because I'm sure that because a lot of the string operations are actually written optimized in C, right? Or I think it's C or PyC or whatever. But so like you may get more performance doing something funky or even like quote unquote suboptimal. So I don't know. I don't worry about it. All right. There was a follow up, but I missed it. Suppose there's a lot of incoming. Yeah, I mean, right now I do for C and S. So in that case, I'll do for every character in T, and then basically you have n point or k pointers. Wow, there's a lot of k's. Oh, I see. Maybe I misread this. Wait, yeah, okay. I misread this, so let's not do that. So I mean, the idea of then probably is just that we have to pre-process T in some way. And the way to kind of do that is that right now we, right now we basically increment by 1, but really we know what we're looking for, right? What we're looking for is C, and this actually comes up in other problems. I just kind of got lazy today, I guess. Well, I just didn't really think about optimization even until this follow-up, so that's kind of good. But yeah, we already know the C that we're looking for, so if we keep track of all the C's, we can go to the next one, with a binary search or something like this. Maybe we could even use some kind of now, I think binary search is probably the quickest way to kind of jump ahead. I'm curious whether you can do it like in a linear thing, but or linear in terms of the input side, or S in this case. Don't know. But yeah. Anyway, that's all I have for this one. Let me know what you think. Gonna do the weekly premium palm next. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Boop.